Let's start with thinking about floods as part of a river system. A flood is a natural occurring event. They happen on all rivers, and they can in fact reap great benefits. This is the Nile River floodplain, and floods happened before the big dams came in. Floods happened here regularly, in fact every year. The people along the Nile counted on the floods to bring water to the floodplain so that they can grow crops there. And in fact, the pharaohs' prosperity depended on the annual flood. Floodplains are great for agriculture, but they can be pretty bad places to live. So what is a flood? A flood, by definition, is pretty simple. It's when the discharge on the river is greater than its carrying capacity. Floods vary due to a lot of different conditions. First of all, the amount of rain, the intensity and distribution of that rain. Where in the river watershed does the rain fall? How much moisture is in the soil already? So how much water can infiltrate the soil as opposed to running off and ending up in a river? Seasonal vegetation can change the amount of flooding by absorbing or not additional moisture. The amount of snow and the speed of the snow melting is a significant factor in many floods, and the change of the surface area due to urbanization can make dramatic changes in floodings along certain areas. So if you've taken out ground that might absorb water and replaced it with cement, for example, then you're going to increase flooding by causing more runoff. We measure floods by looking at a graph called a hydrograph, and it's important to spend some time here thinking about this graph and understanding what it's showing you. It's showing, in this case, two different variables as a function of time. The bars are showing rainfall, and then the yellow dots are showing the peak discharge in the river. So if you have a double Y plot here with the rainfall measured on the left axis and the discharge measured on the right. Now, one thing to pay careful attention to or to make note of is that there's a lag time between the peak rainfall and the peak discharge. It takes a while for the water to get into the river and start to rise. And so generally the flood comes after the rain, not during it. Notice that there is an area here marked bank full discharge. That's the line where that's the depth where the river overflows its bank. So this particular flood overflowed its bank from about 42 hours to 72 hours. So about 30 hours it was overflowing its bank. By the way, the discharge is measured in cumecs, very strange measurement. It means cubic meters per second. Now, if you have an area where you've changed the landscape by bringing in a lot of hardscape, you can affect the flood by making it happen earlier and higher. You've moved the hydrograph to the left sooner after the rain, and also much more rapid discharge. So what do we mean by urbanization? How does the landscape change the floods? Well, you've taken away vegetation often. You've paved streets and put up parking lots and buildings, so made hardscape. You often remove topsoil in urbanization, and topsoil absorbs moisture really nicely. You have commonly changed the topography, and that can change how the water runs off. Storm and sewer systems gather water and funnel it to a creek, and which then can funnel into a river, and that can increase flooding pretty quickly. You may very well have modified natural river channels and built things in floodplains. And of course, a flood is unimportant if it happens where nobody is. But if it happens where there are buildings and people and homes, then it causes significant damage. So building on floodplains is another way that people get more affected by floods by urbanization. The result of urbanization is a higher discharge, higher stream velocity, faster runoff, and increased potential for erosion, which is important as well. Now, people measure flood probability by something that we call a recurrence interval. How often do you see a flood of a particular size? So we talk about 10-year floods, 100-year floods, etc. If you were to measure flood size for 1,000 years, then a 10-year flood is a flood that happened approximately 100 times in that 1,000-year period. So that's the level of the 10-year flood. This is really a probability, this measurement. A 10-year flood has a 10% chance of happening in any given year. And it's really important to understand that. In that 1,000 years, your 100-year flood, you would have had 10 of them. 10 times that the floodwaters raised to a particular level over the course of 1,000 years. That tells you what a 100-year flood is. It's really important to remember that just because you had a 100-year flood one year doesn't mean you can't have another one the next. This is a calculation, it's a probability. Regardless of whether the 10-year flood occurred last week or last year or 30 years ago, there's still a 10% chance of having a 10-year flood this year. And you can have one back to back. So this is a graph, and you're going to create this kind of flood map yourself, but this is a graph that shows the size of annual floods. Each one of these dots is a flood. And so you take the floods and how quickly they happen, you put them on a graph like this, and you find out the recurrence interval of every 10 years is a 10-year flood, and this particular set of data, the size of a 10-year flood is about 1,750 or 1,800 meters cubed per second of discharge. A 100-year flood is way out here with about 2,600 or 2,800 cubic meters per second discharge. So this probability is something that you will calculate and figure out for a flood near you. So is it possible to prepare for a flood? Well, often it is, because the flood has to move downstream at a particular and known velocity. So if your town is downstream from where a major river like the Missouri or the Mississippi is flooding, you very often can estimate pretty closely when it's going to get to you and how high it's going to reach. And so you can do things like build levee systems to try to stop the floodwaters. Now, one thing that is more difficult to prepare for is a flash flood. Flash floods are the #1 related weather killers in the United States, and they're caused by very high intensity rainfall for a short duration, which causes very intense flooding. They're quite common in central Texas, which is sometimes called the flash flood capital of the U.S. This is a picture of a flash flood. This is Pedernales State Park, where with its typical flow and 5 minutes later, the flash flood that came through. But look at the sky. The interesting thing and the frightening thing about flash flooding is that it doesn't have to be raining for it to happen. The rain is upstream from where you currently are. So you can get a flash flood on a river on a perfectly beautiful day. Pay attention. Another picture of a flood. This is the Colorado River in Austin, Texas, taken in 1935. And this is the hydrograph of the flood in Wimberley, Texas in 2015 that was so very destructive. Notice that the flood discharge goes off scale and stays off scale for quite a while before it comes back on. The river was so high and it rose so fast that people were caught quite off guard. This is the Mississippi River in 1993, a flood that was deemed a 500-year flood. There was about $10 to $12 billion worth of damage in that flood and 50 deaths. And this is a hydrograph of that flood. So look at the flood stage in this particular location in St. Louis, where the flood stage of the river is 9.14 meters high above above base level, and it stayed flooded from June all the way until September. So why did we get such a huge flood in the spring of 1993? Well, several things kind of came together at once to make that 500-year flood happen. First of all, there was a tremendous amount of rainfall, about 150% of normal rainfall. Second, the ground was pretty well saturated. There had been cool conditions the previous year, and so less evaporation, so the ground was pretty wet to begin with, and therefore the water couldn't be absorbed. And finally, the river system had been altered for the last 100 years or so, and that made a big difference. So the floodplain was changed by humans to accommodate agriculture and urbanization. 80% of the original wetlands along the Mississippi River have been drained since the 1940s, and that's created a situation where floods can be much worse, much faster. So in a bit, we're going to do another lecture about what to do about floods.